Following on from the previous video, I'm now going to give you an example. So let's say you've been given this sequence here. So to generate our first term, we would put 1 into this n here. We would put 1 into this n here. So put 1 into here. So 1 plus 1, that would be 2. And then put 1 into here. 1 take away 1, that would be 0. And then put 1 into this n here. That would then give you this. So A1 would be this. But the thing is, you've got something divided by 0, so it breaks down. So we're going to discard our first term. We are going to discard our first term and start with A2. So when it's A2, you would put the 2 into this n here. Put the 2 into this n. So put the 2 into the n. So now it's 2 plus 1. That would be 3. Put the 2 into here. That would be 1. Put the 2 into here. That would be this 2 here. So A2 gives you this, and do the same for A3. That will then give you this. A4, that will then give you this. A5, that will then give you this. So what we want to know is what we want to know is that as n tends to infinity, as this sequence goes on and on and on and on, what will be the limit of this sequence? So this is what we want to know. So as this sequence continues all the way towards infinity, what will be the limit of this? So to understand this, so to understand this sequence in your mind, you should be visualizing this. Hang on. Well, we don't know what this sequence looks like, because as things stands, there's no way in the world you can tell you can tell where the limit of this sequence would be as n tends towards infinity. So the way we would do this is to visualize this sequence in your mind. Visualize it like this. Well, we don't know what the sequence looks like. Let's just imagine it to look something like this. So it's heading towards some sort of limit, and it is this limit that we want to know. You see, we don't really understand this sequence. We are just going to guess that it looks something like this. But the thing is, we are going to map a function on top of that sequence. So we are going to map our function. So let's just map this function here. Hang on, x minus 1 to the power of x. So map this function on top of our sequence. So it will then look something like this. So this function will always lie on top of our sequence. Now we don't really understand our sequence, but we can use our knowledge of functions to understand the sequence. Okay, so as things stands, we don't really understand this sequence, but then we would map this function, which happens to be of this form here. We would map this function on top of our sequence, and then use all our knowledge of functions in order to understand our sequence. So ultimately, we want to know our sequence as n heads towards infinity. So basically, we want to know this capital L, and this thing here, what we want to know is really capital L. So capital L here is going to be this. It's going to be our sequence heading towards infinity. So to understand our sequence, in your mind, visualize the graph to look something like this, and then map our function f of x. Map our function x plus 1 over x minus 1 to the power of x. So map our function on top of it. So this is what we want to know. We want to know this sequence as n tends towards infinity. So let's try and do it now. Hang on. So this is what we want to know. We want to know our limit. We want to know capital L. Well, capital L is really so treat this as a function as n tends towards infinity. So you want to know the limit of this as n tends towards infinity. Remember from our section on L'Hopital's rule, whenever you have one thing to the power of another thing, the thing that should be in your head would be natural log. So whenever you have one thing to the power of another thing, then think about natural logs. So take the natural log of both sides. So natural log this side, and when you natural log this thing here comes down here. So it would be this. So it will be this thing here. So from here, natural log equally to both sides. That will then give you this, and then so here you've got one thing multiplying with another thing. So now as n tends towards infinity, you've got infinity times, and then this thing here happens to be a 0. So here you've got you've got infinity times 0, and the reason why this thing here is 0 is because of this. If you look at this thing here, as n tends towards infinity, you've got one bubble dividing by another bubble. So as n gets really big, this one here is going to be negligible. It's going to be nothing. It's going to be next to nothing. So here you've got one bubble divided by another bubble. As n tends towards infinity, this one here is going to be negligible. So you can think of it as being n. And then this thing here, as n tends towards infinity, you're taking away a tiny bit here, a negligible amount. So it's really going to be n over n, which is 1. So this bubble here, as n tends towards infinity, this is going to be the number 1. And then if you look at the natural log, it looks like this. 1 is here. So the natural log is this block here is going to head towards 0. This thing here is going to head towards 0. So you've got infinity multiplying with 0. So when this happens, remember here you've got a product of, well, remember when you get to this stage here, infinity times 0 here, remember this trick from our section on L'Hopital's rule. If you have one thing, a times b, that's the same as b divided by 1 over a. So these two are the same thing. So this would be a trick that we would use, and it has always been, we have always used this trick. So now rewrite. So here you've got a product, rewrite it as a fraction. So rewrite this. So this thing here is this, and then imagine this as being 1 over n. So now it really boils down to us it now boils down to us trying to evaluate the limit of this as n tends towards infinity. I will continue in the next video. Okay.